Hello all, this is a continuation of previous video. Previously we have worked with optimizers with RNN, and in this work we are going to work with another optimizer with RNN and going to compare the different optimizers results and going to make an finalization with which optimizer is providing better results. For that we are initially making and importing the libraries which we are needed. Then we are loading the data set. So this is the data set. This data set we just downloaded from Kaggle. You can give us heart disease prediction Kaggle. In that case, you will get this data set. This data set is having nearly 14 entries. Among that, the first 13 entries we are using as the X variable. The last entry, which is the target one, we are using as the Y variable. Then where we are getting the info of data set. From that, you may notice that the only one variable which is old peak one is float type and all others are integers. Then we are getting the null values of the data. From that you may notice that every datas are not having any null values and it is showing 0 only. If it is having any null values means we have to work with some pre-processing functions. Then we are just displaying the heat map of the data set. So this is the heat map of the data set. Then we are declaring our X variable and Y variable. As I said previously, in X variable we are dropping the target variable, and in the Y variable we are using only the target variables based on this X variable and Y variable. And the test size is 20%, that is 0.2, 20% for testing and remaining 80% for training. We are determining variables like X train, X test, Y train and Y test. And then we are using standard scalar. This standard scalar is used with the X train and X test function. So we are just converting these variables to vectors, and then we are getting the shape of the data. And also with mostly some deep learning networks like CNN and RNN will work with only three-dimensional data. So we have to convert our data to, but here you can notice that this is the shape of the data and it is two-dimensional only. So we have to convert it into three-dimensional. For that we are using the reshape function. The reshape function is converting the two-dimensional data into three-dimensional. This three-dimensional 13, 1 only we will be using as the input shape within the neural network, that is recurrent neural network. So this is the layer composition of the recurrent neural network. So initially it is the sequential layer, next to the simple RNN layer, followed by the input shape 13, 1 activation as ReLU, then the final dense layer which is having the output dimension as 1 because our work is a binary classification work and the activation as sigmoid. So mostly in binary classification work we will give the activation as sigmoid only, and then we are printing the summary of the layer contribution. So this is the summary of the layer contribution. Then we are compiling our model by using loss, binary cross entropy, optimizer as Adam, matrix as accuracy, and we are training our model by using the fit function by using the variables X train, Y train, validation data, and we have done for approaches nearly 50 approaches. Then we are just displaying the graph of the model. So I think this is not displayed the graph of the model. So I am just giving the run all function. So it is running. We shall wait. So before that we can just check with the other descriptions. So here we are also displaying the classification report of the model. So once the work execution has been done, the classification report parameters like precision, recall, F1 score will also be displayed. So the execution has started. Then we are defining the confusion matrix, and also we are defining the confusion. Okay, I shall wait. So here the graph is not plotted, but we can just see at the end at the end it would have get plotted. So this is the classification report, and then we have displayed the confusion matrix for this RNN with the Adam optimizer. Then we worked with the CSGD optimizer, the layer contributions and all same only. The only difference you may notice is previously this will be Adam, now it is DSGD, and it is also getting some 50 approaches for values like loss, accuracy, validation loss, and validation accuracy. And we have got a precision, recall, F1 score, and support. Here also we are displaying the confusion matrix. Then we are displaying the rmsprop optimizer in this work. So here you may notice that here also we have worked for nearly 50 approaches, and then we have displayed the classification report, and the confusion matrix plot is also given. Then we are making a comparison. By comparison, you may notice that this Adam optimizer and this RMS is both more or less providing the same result only, because they are merging one on other. But SGD, you may notice it is a very less when compared to this Adam and RMS prop. The same with loss. Thank you.